Okay, so we are working on our forces in motion. We're on the basics. We have a red team and a blue team, and it looks like we're going to play around with some tug of war. Let's put this guy here and this guy here, and then we'll put this red guy right here. So this is it's showing me some arrows right here, and this arrow is bigger. So I'm guessing because he's bigger. Maybe let's put another person up here and see what happens. Okay, yep, so it's definitely got to do with these people because now the arrow is bigger on the left side. Let's hit go. Oh, see, they're pulling. Let's bring up another guy. Oh, it looks like they're pretty equal to me. However, the blue team's still pulling. And it looks like they're going to win. I guess that's because they had more motion when it started before I added this new guy. Let's return. Now let's see what these do. Let's see what these are. Sums of forces. Okay, so it tells me. Oh, now it's going to give me newtons. Okay. Oh, and I got a little speedometer there. Alrighty. Let's try this again with these people. Let's see what happens. Nothing happens because it's the same. They're equal. Now let's add this guy. Alright. It's going this way. And you see the speed going up too. Oh, now we have this guy. Will he be able to pull it back? Ooh, it looks like it. Looks like he was added enough time to take away from their momentum over here. Let's add this little guy now. See if it works. Oh, it doesn't look like. I think the blue team had too much momentum. Yep, blue team wins. Okay, now let's put him back. I think it makes a lot more sense now that the speedometer and the values and sums of forces are brought up. I think that helps a lot with some gray areas of not quite knowing what was going on. The arrows initially helped in the beginning, but having those numbers there, it really does help because before you're just relying on the size of the people versus seeing the actual numbers. So 2 red people equals 100 newtons toward that. This one blue medium-sized person equals 100 newtons as well. And when you add a little person on, that adds 50. So let's add this medium guy on. That adds 200. So he is 100. And these little guys are 50 newtons. And the big guy is 150 newtons. So if we hit go right now, I bet you this thing's going to take off in the direction of the red. Just because of all the newtons over here added up together is 350 versus the 150 newtons. So the difference is 200 newtons, which makes a pretty big difference. Yeah, look at that speedometer go. It's flying up there. Yep, that was quick. Now if we add this one here, now it's just 150 difference. Let's take away one of their 50s. So now it's just 100 difference, 100 newtons. Let's see if it's as fast. Oh, it's taking its time a little bit, but it's getting up there. Now let's add this big guy. Oh, it did start to slow down some. Let's do that over again. I'll add him quicker and see what happens. So it's getting up there. Now let's add him. Wow, see, look at that. The speedometer's dropping. Which that's really cool because then you get to visualize the speed that is taking place. Now let's add him back. Oh, it stays the same. But it stays the same and those are the same. So I think in order to pull it back again, you would have to add another red person on here to take away from the blue team's momentum. So you really get to see how the force and momentum go hand in hand. If the momentum is going in one direction extremely high, you need to put in more force on the opposing side in order to change the directions.